last video, we're going to talk about evaluating indefinite integrals, which is a lot like finding definite integrals, except you don't have these bounds. So what do you do when you don't have these bounds? The real difference is that this is defined right here. The integral of a function equals the antiderivative of x plus this c, where c is any constant. I want to explain why that is. So why you need the plus c. So let's do this kind of backwards. So let's take the derivative of two different functions here. I'm just going to draw this off to the side. So let's do over here something simple, 6x plus 1. And let's over here do 6x minus 2. The derivative of this first guy, the derivative of 6x plus 1 is 6. The derivative of this 6x minus 2 is still 6. Therefore, if I want you to find the integral of 6 dx, you would say, okay, well, what can I derive to get 6? Well, that is for sure 6x, but you might have had a constant there, like these two functions up here. We had constants, but it just didn't show up in that derivative. So we say plus c because we say, well, there might be a constant there, and there might not be. It might be 0. But the thing is when you integrate, you just aren't sure when it's an indefinite integral because you don't have those bounds. So we say, okay, well, the derivative, or the thing that will, when you derive it, gets a 6 is 6x. But there might have also been some constant attached to it to still get us a 6 when we derive it. So that's why you need that plus c. So now we'll walk through some examples. So we'll evaluate the following indefinite integrals. So this is kind of like last week, you have to say, okay, well, what could I derive to get this integrand? So for this one, you raise the power of the exponent. So this is definitely going to be x cubed. And then think kind of backwards here. If you take the derivative of x cubed, you get 3x squared. But I need a 6x squared. So I'm going to multiply this by 2. So that now when I take the derivative of 2x cubed, we get 6x squared, which is exactly what we wanted. Minus this next term, we have an x to the power of 1, which I know I'm going to make to the power of x squared, or just to the power of 2, x to the power of 2. Now, okay, if I take the derivative of x squared, I get 2x. Perfect, and that's it. Plus c. So that's part A. Part B. So remember with derivatives, you can pull out constants. You can do the same for integrals. So I can say this is equal to 4 times the integral of e to the 2x. So this is equal to 4 times the integral of 2x. Well, the integral of e to the anything is still that e to the anything. But chain rule says if I take the derivative of e to the 2x, I'm going to end up multiplying by a 2 here next to it, which means that to counter that, I'm going to have to multiply by 1/2. So now test it out. If you take the derivative of this whole thing, 4 times 1/2 e to the 2x, do you get 4e to the 2x? You do. Sorry, I didn't write plus c here. So the answer here is 2 times e to the 2x plus c. Next up, let's integrate sine to the 2x. Alright, what can I derive to get sine? That'll be a negative cosine, because remember the derivative of cosine is negative sine, so to cancel out those negatives, we need to add a negative out front. So it's going to be cosine of 2x But when I take the derivative of this guy, I'm going to do the chain rule, and I'm going to end up multiplying by this 2 here. So to counter that, I'm going to multiply by 1/2. Whoa. Times 1/2. So this is equal to negative 1/2 times the cosine of 2x. So double check. What do you get when you take the derivative of negative 1/2 times the cosine of 2x? You get sine of 2x. Last up, the derivative of 1 over x. Sorry, not the derivative, the integral of 1 over x. This one is one that you're going to want to start recognizing because this one is the natural log of x. Oh! Okay. Plus c. I made a mistake. Plus c. Over here too. Because it's an indefinite integral. And we don't know if there's a constant. So we need a plus c here. Plus any constant will get us this as a derivative. Okay, so because remember so back to part D. Sorry, that was crazy. Okay. So the integral of 1 over x dx equals the natural log of x plus c, because the derivative of the natural log of x is 1 over x. And those were just some examples of indefinite integration. There's more practice for you on the next page. Email me with any questions that you have. Have a good week, everyone.